I'm glad to be back for my second year in a row talking about data binding. Did anybody have a chance to catch my previous edition of this talk? Yes? Nice. Thank you. How many of you have had a chance to actually use Android's data binding library so far? Nice. So a good bunch of you. Okay. For the people who didn't raise your hands, don't worry. I'm going to do a little bit of introductory, what is it, why should I use it, before I get into the fun stuff. But yeah, let's get started. So the first basic question people say are, well, I'm kind of intimidated to get into this whole data binding thing. What's the barrier to entry? Well, I'm here to tell you it's super easy. There are 3 steps and 3 slides. So very, very simple. So the first step is to enable data binding in your module level build.gradle file. Simply add this data binding block in there and say enabled equals true. And you're set. That'll get you the annotation processing and all the layout processing that you need to get going. The second step is to wrap any of your existing XML layouts in this new data binding tag, which is called layout, with a lowercase l. And this kind of tells the annotation processor that this is a special layout file that I want you to take a look at. So here is a very, very simple layout. It's a text view and a relative layout. And if we wanted to hook this up to use data binding, simply just wrap it in this layout tag and move the XML namespace declaration up to the top level. And that's step 2. So the final step to using data binding is to inflate your layouts a little bit differently than you might normally do so. So traditionally in an activity, if you're setting the content view to a layout file, you would just call this activity method setContentView. So if we want to use data binding, just change that up a little bit and use the data binding utils method for setContentView. So then the first parameter is the activity, and the second one is the layout file. There's a couple different ways to do this. You're not always going to be inflating in the context of a layout. You might be using a custom view. But data binding util will have all the methods that you need in order to inflate your layouts using data binding. So there you go. The great part about this process is that it's not like a big deal. If you want to experiment in your existing application, all you need to do is start one layout at a time. There's no commitment to migrate your entire app to use data binding. So if you like what you see, give it a shot on 1 or 2 files, and then maybe make your way to the rest of your app in time. So the next question that you might ask is, why should I use data binding, or should I use data binding? And I have to say that the question that I get from most of my friends and colleagues who do Android development is, you gave this talk on data binding a year ago. Do you still recommend it? Do you still like it? And I would say concretely the answer is yes. I'm very much a fan of it, and I recommend it for everyone for a few reasons. So let's go over those. First of all, the first and foremost definitely is that you get to separate your UI logic from your activities and fragments. There's a lot of different complex architectures for building applications like MVVM, MVM, MVC. So data binding has a simple way of keeping your view logic out of your activities, which is really quite convenient. So in this example here, I'm adding a new tag into my layout file, and it's just a data block. And within that data block, you can specify variables. So rather than finding this text view by ID from my activity, I am simply going to pass in a variable to my layout, and then I can refer to that variable in the layout directly. So anybody looking at this file can see exactly what is going to be on the screen at runtime. Whereas if you had a text view and you were going to look it up by ID in your activity, you'd kind of have to cross-reference between the activity file and the layout file to see what's going on. So data binding has this really strong advantage of being really declarative, and the layouts are very expressive about what their intent is. So you may ask, well, what is this syntax with the @ sign and the curly braces? And there's been a lot of theories about what this should be called. I refer to my good friend, Matthias, for an answer to this question. So we call it the data binding mustache or goatee. And as a wise man once said, the binding mustache's ways are mysterious and subtle. So remember that. If you're ever confused, there is rhyme and reason to it, but it's just mysterious and subtle. So the second part of setting variables in these layout files is, well, you need a way to actually set a variable in a layout. So when you're inflating layouts the normal way, you just kind of call a method that returns void. You say, okay, layout inflator, inflate my layout. Or it actually would return a view. So the difference between data binding layouts and regular layouts is that instead of creating a view, the class that backs them is called a binding. So these classes are actually generated for you by a preprocessor, annotation processor at compile time. The default naming convention for these files is just to take like whatever your layout file is, for example, activity_main, and it kind of camel caseifies it and puts the word binding at the end. And you can customize that, but I haven't really found a reason to, so I've stuck with it. So here's the example we showed previously where we just basically inflated a layout using the data binding util in order to leverage data binding. And if you want to set a variable on this layout, the trick is just to save the resulting value from inflation into this binding variable and then set the variable on it through code. Now, so the layout inflator is very smart and the annotation processor, and it creates these binding classes that have the variables with methods, setters, and getters for you. So it's kind of magic, but there's rhyme and reason to it, so it's very straightforward. So in addition to basic variable access in these data binding layouts, you also have access to a syntax language that supports pretty much anything from basic to complex expressions. So in this example, I'm passing a Boolean variable in the data block, and then below, I'm setting the button's visibility to visible or gone based on what that variable is. So what this means in practice is that instead of finding a view by ID in my activity and then calculating some business logic to determine whether or not I should show or hide that view, all of the logic for it is directly in my layout. And this is even more powerful when you're using less primitive types, like for example, a user object could be passed in to this layout, and you could show different fields based on if what their birthday was, or you name it. So the next benefit I want to talk about is that you never have to use find view by ID again. And I've talked about how it's so terrible in the past, and I will just briefly reiterate how terrible it is. It's ugly, and it's unsafe, and it requires casting. So whenever I'm sure this has happened to all of you using find view by ID, you're going to create a layout and you're going to have a text view. But then later on you realize, oh, I actually need an edit text, or I need some other view. And you keep the same ID, so it still compiles, but then at runtime it crashes because it's actually not an instance of what you expected it to be because you changed it. So that's an example of unsafe casting. We want to avoid it at all costs. And of course, many libraries have solved this problem already in different ways. For example, Butterknife or Evan Tatarka's Holder, lots of ways to do it. But I think data binding provides the most elegant solution for it at all, because every single view that has an ID in a layout, in a data bound layout file, is going to be pushed into a field in the binding directly. So if I have a text view called first name, then there's going to be a field on my binding class that refers to a text view that will never be null and perfectly safe to access from code. So next, this is another great feature of data binding. It has graceful handling of null object references. So say, for example, in your layout, you had a variable called user, and that user variable had a car property that may or may not be null. Not everybody owns a car. And that car could also have a color. So if you wanted to refer to the color in your Java code, you would have to check first if the user was null, and then make sure the car wasn't null, and then access the color of the car. So that's about 6 lines of code, a bunch of curly braces, terribly ugly. So the developers of data binding were like, okay, let's make this easier for developers. So basically, the way that null checks are performed is that it will just short circuit to the default value for the type. So for example, in this case, color is going to be a string. If either user is null or car is null, then the expression will short circuit to null. So no null checks are ever required. There's also something called the null coalescing operator, which is the 2 question mark sign, and that would allow you to provide a default value if you didn't want to use null. So for integers, for example, the default value is 0. It's very intuitive, and it makes your life coding a lot easier. So finally, and perhaps the most powerful feature of data binding, is that you can automatically update the UI to reflect changes to the data model. So the way that this is powered is by this base observable class, which is provided by the data binding library. Whenever you have a variable that extends base observable, changes to that variable will automatically update the UI. It's actually really quite simple and powerful. So there's a bunch of different approaches to using base observable, and I want to talk about a few of them because some of them are more simple and more complex and more powerful and less efficient. But I'd say that there's a use for all of them. So the first one, it's the most specific and efficient way of doing it. Basically, if you annotate a getter on one of your variables that you pass to a layout with this bindable annotation, then you can tell the model whenever that property changes explicitly. So in this case, I have a method called setName, and whenever I modify the variable, I notify the data binding system that that particular property has changed. So a lot of people are going to say, oh, well, what is this br.name nonsense? Well, it's a very familiar concept if you've worked with Android at all, because for every ID that it's in a view, we have a generated constant in the r.java file, which represents resource IDs. So BR basically stands for binding resources. So whenever you annotate a field or a method with bindable, that tells the system that it's an ID that we need to keep track of and we want to be able to update in real time. So the next example that I want to show, well, you can see this is a little bit of boilerplate. You know, you have a getter and a setter and a private field. You might want a solution that's a little more simple and easier to write. So we have this concept of observable fields in data binding. There's also observable primitives like observable booleans and observable integers, but I'm using observable fields here because the data that I'm working with is a string. So basically this one line accomplishes everything that my previous example did. So the interface for this observable field is basically just a get and a set. So you can have observable field.get and observable field.set. And whenever you call set, it notifies data binding that that property has changed. So I'm a big fan of these guys. I tend to make them public and final and just skip the getters because it's, you know, perfectly safe approach to doing it. And then if you want to look at some code of how it would work in an activity, basically just create my user object and then set a value for it and then set it to the binding. And then later on, anytime that I updated that value, it's updated in the layout. And the way that you access it in the layout is just very simple. It's the same as it would be otherwise. So the final example that I want to talk about for updating views is this notify change method. And this is kind of like in an adapter. Like for an example, for a recycler view, you can call notify dataset changed, but then you lose the advantage of like animations or the context of which item was updated. And it's a little bit less efficient. But sometimes, like for this example, I'm working with a class called a view model, where basically it takes a user as an input and then it maps to the layout how the user should be represented. And basically, if the user is changing, I can confidently say that every getter in this class is going to need to be updated. So sometimes this is appropriate, even though it's kind of just like a smack in the face, like, okay, update, but it's fine. So I tend to use this a bit too. And the convenient thing is that regardless of which approach to observability you're using, the way that it looks in your XML is the same. So if you decide that you want to make it more granular and only update a certain field, your layout doesn't change, just your model. All right, so wow, I actually talked quite a bit about the benefits of data binding, but now I think it's time to move on to how it works under the hood. I'm going to go over this briefly because I don't think it's too relevant to a developer on a front-end application, but it's important to know how it works. So first of all, you have your compile time layout processing, which involves 4 main steps. First of all, it processes the layout files. You have to keep in mind that data binding is backwards compatible to Android 2.1. So if you were to pass a layout file with all these variables and expressions to the layout inflator, it would just not know what to do on Android 2.1. So what the system does is it actually strips out all of the data binding expressions and variables and all that stuff and converts it into a raw layout file. Then it takes those expressions and parses them. So the grammar for data binding was designed with a very heavy emphasis on performance. Data binding kind of has a bad reputation for being slow and inefficient and sometimes using reflection. So this was definitely a huge goal. They want to parse these expressions as efficiently as possible and make sure they don't impact performance. So for example, if you had a complex ternary expression that had maybe 5 nested question marks, and I mean, you would never want to do this, but if you did, each part of that expression would be parsed individually and cached. So if you made the same calculation several times in your layout file, it's actually only calculated once. So the third step in this process is that basically the dependencies need to be resolved. Your layout files are going to be accessing variables and static fields. So the third step in the process is just to gather those all together and make sure everything works and resolves fine. Otherwise, you get a compilation error. And finally, the binding classes are generated, which kind of ties everything together. So we've talked quite a bit about those, but yeah, that's basically the compile time process for it. So the next thing that I want to talk about for how data binding works is how do we deal with things that you want to display in your layouts that aren't necessarily supported by XML attributes. So data binding supports these things called automatic setters, which basically allow you to have more control over your layout than you might have with the traditional XML attributes. So for example, if you had a drawer layout in your layout file and you wanted to set the scrim color, there's actually no XML attribute to do that programmatically without data binding. So what data binding does is it looks at the class drawer layout and says, can I find a class that matches this method and call that automatically? And conveniently, yes, there is a method called setScrimColor on drawer layout. So basically, it allows you to just kind of use a little magic to make your life easier. Same story goes with the drawer listener. And I just want to make a quick note that you can see in this expression, the data binding mustache is referring to a color resource within the data binding expression, and that's totally fine. You can access all sorts of resources. You can actually do string formatting and actually quite a lot of stuff that's not very well documented, but you'll find that once you start playing with it, that it's a little bit more powerful than you'd even expect. Yeah, so a lot of time the automatic setters where it's trying to find a method that's appropriate for your XML attribute, it's not going to have a perfect match. So this concept of binding methods is actually something you probably won't have to worry about. You'll just be able to take advantage of without even realizing it. But the data binding team basically mapped a lot of methods to more intuitive XML attributes. So for example, if you wanted to set an on-click listener for a mouse event or a touch event, rather than saying Android on-click listener equals model.listener, they simplify it to on-click. So basically, if you're just trying to write code and hack things together, most of the time you're just going to get it right without even realizing it because they kind of want it to be intuitive. So next, I want to talk about a more complicated case. There are a lot of properties that don't have convenient setters. So in that case, we need to write some sort of adapter to adapt the data in your layout to set the values. And the most prominent example is for padding. If you've ever looked at the view class, you'll realize that there is no method to set the left padding on a view unless you set the right, top, bottom, and left at the same time. So basically, a binding adapter is going to be something that you'll write or something that's written for you in the case of this one that will make it easy to set these properties that don't have setters automatically. So this is actually stripped directly from the library code from data binding. Basically, it just says if you want to set a binding adapter for padding left, simply pass us that value and then we'll set the left padding and use the existing values for all the other ones. So binding adapters are really complex and powerful, and so many of them are provided for you. I just wanted to point this out because I feel like many people aren't aware that all these resources are available to look at. If you're in your Android Studio, you can simply say, I want to see if there's a binding adapter to bind a date to a calendar view or something. So just pop open this class, type in binding adapter, and you can see through all the existing files that are written for you which binding adapters exist. And some of them aren't there, in which case you need to write your own. But for the most part, they're all there for you. So this is a quick example of a binding adapter that almost all of you will probably write yourself if you use data binding. So the data binding team did a great job of writing most of them for you. But in the case where you need to do something asynchronous or that's dependent on a third-party library, then this is where custom binding adapters really shine. So I just want to point out the structure of this method. It's got the annotation at the very top, and the value is called image URL. That value represents the XML attribute that you'll use in your layout file to set this. So the method parameters for this class, which, by the way, is a static method, the first method parameter is always going to be the type of view that it's operating on, and the second is going to be the XML attribute input. So for example, if I tried to use this binding adapter on a text view, it would not work because this particular one only accepts an image view. But yeah, once you have the two parameters, all you need to do is just load your image using Picasso, and then it fires off asynchronously and takes care of it for you. So this is obviously a very, very dumbed down example. But in practice, you'll realize that you can do more advanced things. Like in this case, I have 2 parameters, and they're not all required. So it has optional parameters. So I can, if I set an image URL XML attribute and a fit XML attribute, if it has the fit one, then it will basically perform the logic differently. The point is that you can have a huge list of parameters and have them be optional and operate on all at the same time. So I wanted to quickly include a brief little snippet of a file that you might see in DramaFever's codebase. It's actually shortened a little bit because it's even longer than this, but this is just the method signature. We basically mapped out the entire Picasso API to a single binding adapter, so we can make any type of image loading request directly from XML. Awesome, so we've gone briefly over binding adapters, and the last and coolest thing that I want to talk about in terms of how this works behind the scenes is event handlers. So this is a very basic example of a button that has a click listener specified. So when you look at this, you're like, okay, this method is going to be deferred to a button click handler. And you'd wonder, well, is it going to be a method, or is it going to return a click listener, or what? So the most basic way of doing it is to create a method that returns a click listener. It's a little verbose, but it gets the job done. Fortunately, the data binding team, again, wants to save us time. So they basically analyze the interface that's required. So the view.onClickListener has to implement this particular interface, which has one method, onClick, that accepts a view. So they took it a step further, and they say, well, if you write a method that has one parameter and it matches the method signature of the event that's required for the onClick event, then you don't even need to return onClickListener. You can just call this void method. So basically, it just encapsulates it for you and makes it very simple to write an efficient click listener. Cool. So now, believe it or not, I wanted this to be like a very, very brief introduction to the cool stuff that I wanted to talk about now. But I guess I got carried away. So what is new in data binding since I/O 2015 when they announced it? Well, Java 8 is new with Jack. Android applications are going to be starting to support lambda expressions and method references natively. So data binding should support them too. So this is a previous example of how we had a click listener for a button click event. Well, let's make this a little bit more concise and change it into a method reference. So the issue with the version that I have crossed out here is that the event handler .button clicked makes it looks like it's accessing a property or a method on my event handler. But it doesn't have any parameters, so it's like ambiguous and not clear, and it caused a lot of confusion. So they decided that it would be more concise and clear to deprecate that, and instead, if you want to refer to a method directly, use a method reference, because the implication there is that there's going to be, it's going to require that view parameter. If you've worked with Java 8 method references, it makes perfect sense. So in addition to method references, we have lambda expressions. So here, once again, it's even more explicitly saying that we know the onClick listener has one argument, and it's a view. So we're going to use a lambda expression to pass it to a specific method in our model and pass the parameter explicitly. So in addition to being able to pass the parameter explicitly, you can actually not pass the parameter. So if you decided you didn't need that view reference, I mean, I can't tell you how many times I've had to add a comment saying no inspection, unused parameter when I'm writing a click listener, because it's just simply not something you need. So if you omit it, it works just fine. And that allows your event handlers to be even more concise. But there is a catch here. If you are writing lambda expressions for events that have multiple parameters, for example, like the check change listener on a compound button, basically the rule is that it needs to be all or nothing. So you can pass both lambda parameters to the method, or you can pass none. But you can't pass one, just because there wasn't really a great way to parse that, and how would they know which one you wanted? Sweet. So next, another hidden feature that's not really in the documentation at all is that they've added these magic variables for you. First and foremost, context is available anywhere. So in this example, I have an onClick listener that passes a context which is not declared anywhere but magically works. Now, I personally haven't found this very useful because I'm a bigger fan of dependency injection. I would rather pass that context variable into my event handler in the constructor. but I can see how it might be useful for some folks. Oh, that's a good question. I believe it's the context that's used to inflate the layout. So whatever you pass into the layout inflator. Yeah. Okay. So another set of magic variables are, now this is actually very, very cool. You can actually refer to other views by their camel casified IDs. So in this example, I have an edit text called input name, and then a button which calls an event handler that passes that edit text into it as a method parameter. So in that event handler, I could like make an API call with the reference to the string that the user had entered in the edit text. And then in your method, you just pass it as the parameter there. Cool. So next, two-way data binding, another fun topic for me. Again, not really covered in the documentation. But if you use this equal sign binding mustache, oh boy, is that me? If you use the equal sign in your binding mustache, which is like the little thing here, then basically you indicate that you want to use two-way data binding. So in my example here, whenever the user edits that edit text, the value gets persisted back to user. So for example, if you were given a user object by your API, and then you wanted to have your user modify it in real time, and then send it back, that would work just like that. Okay. So here's another example of using two-way data binding. The user edits the name, and then it shows up in a text view below that in real time. So as soon as you edit the username, it says, hello, your name is username. Cool. So two-way data binding is actually powered by this concept of inverse binding adapters. I spent quite a bit of time covering binding adapters, but inverse binding adapters, instead of formatting the data to display on the screen, do the exact opposite. So in this example, I have an edit text and a text view, and the edit text name property is actually printed here directly. So it's kind of subtle the way this works, but this name property on input name in my data binding expression has to be populated from somewhere. So you'd ask yourself two questions about how this works. How am I going to get the name from this edit text directly in a data binding expression? Actually, quick example of how that works in real life. So that requires no code. It's just a simple data binding expression. So how does it work? First of all, where does the data come from? And how will the data binding system be notified when that value changes? So to answer the first question, we look at the implementation of this inverse binding method. Basically, it's a way of mapping a method on an object to a data binding expression. So we say, when a data binding expression refers to this Android text attribute on a text view, then call the getText method on that text view to fulfill that request. So in the library, they have all these inverse binding methods for almost all the views that you're going to work with on a daily basis. But it allows you to access the properties of views directly in your data binding expressions and have them be updated when the expressions change. So how do we know when to update the text view? So that's what this event field for is in the implementation of inverse binding methods. Basically, data binding invented this weird concept of events, which doesn't really mean anything outside of the context of data binding, but you associate a given event with a view, and then you write a binding adapter to notify the view when that changes. So quick example of that, I realize this is getting kind of deep. So in your binding adapter, we've talked a lot about binding adapters before. You have this static void method that has a view and then a parameter. So if the second parameter is an inverse binding listener, that means that this binding adapter exists for the explicit purpose of notifying data binding when something changes. So what this method is doing is basically attaching a text change listener and then basically saying, yo, when that text just changed, I'm going to trigger this event on my arbitrary inverse binding listener, which is just a construct that exists within data binding to make it work. So it's very rare that you're going to have to implement this yourself, but if you do, it's good to at least know that the classes exist. So I'll leave that there. Finally, there's sometimes a case where you're going to get a return value from a method on text view. Like, for example, we've been talking about the text property. If you want to refer to that directly in a binding expression, the problem is it returns a char sequence instead of a string. So inverse binding adapters basically just take care of mapping from one type to another. So yeah, that's the fun part of that. Finally, dependency injection support. I've had a lot of people talk to me, and a lot of people who are like, I'm not going to touch data binding because all these binding adapters have to be static methods. How am I ever going to write a unit test for that if it's static? So this question perplexed me for quite a while, and even though I was told that there's a way to do it, the documentation didn't cut it for me. So I decided that it would be best to kind of just show y'all how it works. So, and this will actually give you a chance to see how much of this data binding is really just given to you for free, and it doesn't really require too much thought. So in this class, or in this activity, I have two classes, an activity, which uses data binding util to set the content view, and then I have an application class, which I'll tell you why I made later, and then finally I have this XML layout. So for this contrived case of needing to use dependency injection, I'm going to write a binding adapter that depends on something that cannot be static. And in the most simple case that I thought of was shared preferences. So unless you have like a singleton application and you're getting that context statically, you simply need to come up with a better solution to access shared preferences in a binding adapter. So let's just say, oh boy. Okay, so I'm going to write a binding adapter right now. We're going to say this XML attribute will be called, what do we want to call it? String from prefs. And basically need to pull an arbitrary string from shared preferences. We'll just call it name. So what I want this binding adapter to do when I finish it is to go into shared preferences and find a string with the key name in shared preferences and then display it in this text view. So in order to do that, we'll need to create a binding adapter. And binding adapters are basically just static methods that can live anywhere. I'll just call this class myBindingAdapters. And just create a static method in here. And what did we call this class? String from preferences. And this name is completely arbitrary. The first parameter has to be the type of the view that it's going to operate on. In this case, it's going to be a text view. And the second has to be the type of value that's going to be passed into the XML attribute, which is a string, because it's a key for shared preferences. Okay, so then, well, how are we going to get shared preferences? I'm not sure, because this is static. Well, we'll think about that. But first, let's make this a binding adapter. And if you recall, the value for the binding adapter is going to be the XML attribute that we created. So if you've ever created an XML attribute before data binding, you realize that the process is really tedious and difficult. Data binding actually gives you a really, really easy way to create custom XML attributes in addition to actually binding data. So we've created our binding adapter, and this is actually all we need to create a binding adapter, but we're still stuck with this problem that we can't access the context because it's static. So fortunately, since last year, or since 2 years ago when they announced data binding, they've come up with a solution for that. If you create a class that has a non-static binding adapter method, then you can actually instantiate it at an application scope or an activity scope and kind of inform data binding about the instance that you want to use. So let's make this an instance class with a constructor. And we're going to pass in shared preferences. Okay, so we'll need to instantiate this somewhere. That's why I created the application class. So we'll just say in our application on create, let's say my binding adapters. This is not really fitting on one line here. Okay, so we've created an instance of this, and now all we need to do is inform data binding that we want to use this instance whenever we need to resolve this binding adapter. So there's this concept called default component. So what do you think is going to be in this class? Well, let's find out. Oh, look at that. Isn't that interesting? So in real time, I haven't even had to compile or do anything. It's already aware of my binding adapter class that I created, and it will allow me to return it whenever it's needed. So there you have it. Dependency injection is possible with data binding. Let's let that myth be dispelled forever. Cool. There's really not much. I don't think it's worth actually showing you how it works in practice because it's not very pretty. But yeah, I thought that would be a neat little example. And we still have a few minutes left, and that was actually the last thing I wanted to talk about. So I'm happy to take any questions or, you name it. Otherwise, check out the DramaFever app. We just released a brand new, beautiful edition full of data binding. Cool.